The electric mains in a house are marked 220 volt, comma 50 hertz. Write down the equation for instantaneous voltage.
So,
Yes,
how many classes will AC take?
I think 3 or 4 classes.
Okay. How many classes will ray optics and wave optics take? Because
Ray optics will take ray optics near about 20 classes. Ray optics will take, and 3 to 4 classes wave optics will take.
if wave optics will take 3 to 4 and 3 to optics before wave optics, because I don't have 20 classes. I don't
Tw-
have time for that. Unless we can take more classes or longer classes and stuff. I don't have any time.
I will try. I will try. Let's focus on this.
Okay.
The electric mains in a house are marked 220 volt, comma 50 hertz. Each 10 of notes. The electric mains in a house are marked 220 volt. So what is this 220 volt? Whenever any voltage or any current is given in any numerical of this alternating current chapter, AC chapter, then you need to understand that RMS value of current or voltage is given. So the electric mains in a house are marked 220 volt. 220 volt means it is ERMS. It is RMS value of the EMF is given. So given given ERMS is equal to 220 volt. ERMS is equal to 220 volt, and then frequency is also given. Frequency is 50 hertz. Frequency F is 50 hertz. They are asking about, write down the equation for instantaneous voltage. So for equation for instantaneous voltage is E is equal to E naught. E is equal to E naught sine omega t. Now we have to calculate E naught. What is the value of E naught? E RMS is given, and now we wish to calculate the value of E naught. So as we have done yesterday, what is the relation between what is the relation between peak value and RMS value? It is given by this: E RMS is equal to E naught upon root 2. Now I want to calculate E naught. So E naught is equal to E RMS multiplied by under root 2. What is E RMS? E RMS is 220, and under root 2 is 1.414. Value of under root 2 is 1.414. So let's multiply both these terms. If I remove this decimal point, then 1 comes in the denominator. And how many digits are there after this decimal? 3 digits. 1, 2, 3. So let's cancel this 0 by this 0 and multiply 22 by 1414. 1414 multiplied by 22. 22 4s are 88. 8 is carry. 22 1s are 22 plus 8 is 30. 3 is carry. 22 4s are 88. 88 plus 3 is 91. 9 is carry. 22 1s are 22 plus 9 is 311. 31. 31108. 31108 divided by 100. 31108 divided by 100. 100 will cancel out and we will get decimal here. So what is the value of E naught? E naught is 311.08. E naught is 311.08. Approximately we can write it 311 volts. Is this clear to you?
So then we write omega t in the terms of f.
In terms of F, yeah. Omega is equal to 2 pi F. Now 2 multiplied by what is pi? Pi is 3.14, and what is F? F is 50. 50 twos are 100 multiplied by 3.14 means 314 upon 100. 100 will cancel out this 100.
Then won't it just be sine 2 pi? If it's sine 2 pi, then can't you
Sorry?
omega
Hmm.
t is equal to 1 by f, right?
Huh.
T is equal to 1 by f.
Huh.
So if omega is equal to 2 pi f and t is equal to 1 by f.
No, 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 no,
So
no.
omega t will be 2 pi.
Wait. Omega is equal to 2 pi f, and this f is 1 upon capital T, and this t is small t. So there is a difference between small t and capital T. Small t is a variable. Small t, this is any time duration, 1 second, 2 second. This is called time taken, and this capital T is time period. Time period is fixed, is a fixed value. It is a constant value, and small t is a variable. So we cannot cut by small t by capital T. Understand?
Mm.
So small t is not equal to 1 upon f. This is not equal to 1 upon f. Capital T is equal to 1 upon f. Small t can take any value. Small t can have any value. 1, 2, 3, 4, 5, 6, any value. And capital T, capital T means the time period after which an AC wave repeats itself. Is that clear?
Yeah, so but then how will you find the sine value of like values like these?
No, I'm not going to find out this value. They are just asking that we have to form the equation of instantaneous voltage. So we have find out here that omega is 314, 2 pi f. Omega is 314. So what will be the equation of instantaneous voltage? Therefore, equation of instantaneous voltage will be voltage or EMF will be E is equal to E naught sine omega t. What is E naught? 311. 311 sine, what is omega? Omega is 314 and t. This is the equation, and in this equation t will always be there. Small t will always be there. Sine will always be there. Understand? Now let's move on to question number 2. Calculate the RMS value of the AC shown in figure. Calculate the RMS value of AC shown in figure. 0, 2 ampere, minus 2 ampere, and small t is there. So calculate the RMS value of the AC shown in figure. RMS value of AC shown in figure. So RMS value, we have calculated that, we have find out in the last class that what is IRMS. IRMS is always equal to I naught upon root 2, and ERMS is always equal to E naught upon root 2. But what is the basic meaning of RMS value? RMS means RMS means root mean square value. That is, we have to find out root of mean of square. Root of mean of square. Now we have three instants of time here. So this is suppose this is 1 second, this is 2 second, and this is 3 second. We can split into another time durations also. Now we can take it x, this is 2x, this is 3x. We can take it like this also. That is also all right. But here, just for the sake of simplicity, I am taking it 1 second, 2 second, and 3 second. So at 1 second means at first time duration, what is the value of current? 0 to 1 second, the value of current is 2 ampere. 1 to 2 seconds, the value of current is minus 2 ampere. 2 to 3 seconds, the value of current is again 2 ampere. So we have three different time intervals. 1 second, the value of current is 2 ampere. 2 second, the value of current is minus 2 ampere. 3 second, the value of current is again plus 2 ampere. So we have to calculate root of mean of square. What is this? IRMS. First of all, we have to calculate the square of every value which we have. So we have 2 ampere, minus 2 ampere, again 2 ampere. Then we have to, first of all, we have to find out the value of square of all the values. So square means 2 square, and mean of the squares. So 2 square plus, then for the second time duration it is minus 2. So minus 2 square plus 2 square. And what will be the mean of these square values? If we wish to calculate the mean, then we have to add all the terms and divide by the total number of terms. The number of terms is 1, 2, 3. We have added these three square terms and we are dividing it by the number of terms. Number of terms is 3. So what is this? This is mean. This is mean of squares. Mean of square. Now we have to calculate root of mean of square. Root of mean of square. So root means this one, square root. Now 2 square is 4. Minus 2 square is again 4. 2 square is again 4 upon 3. 4 plus 4 plus 4 is 12 upon 3. 3 4s are 12. 3 4s are 12. What is the square root of 4? Is 2. So RMS value is 2 ampere. Is that clear to you? Is this clear to you?
Yes.
Okay. Now the next question is, both these questions have come in CBSE exams. That's why I told you these two questions, question 1 and question 2. Alright. Now let's move on to the next topic, phasors and phasor diagrams. Anusha, at what time generally you sleeps every day?
Really late.
Late. And
Yeah.
in the morning, which time you wake up every day?
5,
5. And you sleep by which time?
2.
2. So 3 hours of sleep is sufficient for you. You don't feel sleepy,
Yes, sir.
You don't feel sleepy in the school.
I do, but then I manage.
Okay,
Sometimes I sleep in the afternoon, but then
okay,
I have physics and math.
okay. I'm
I
asking.
sleep in the afternoon.
No, no, I'm asking this thing because if I want to take some extra classes, then I have time only in the night, and in the morning time you wake up at 5 a.m. and then when you go to your school.
My school starts at 7. I leave the house by 6:10.
Oh, so 5 a.m. you wake up, and then by 6:10 you leaves your house.
Yeah.
Okay. And what is the time duration of school? School is of 7 a.m. Na?
7 to 1:50, 2 p.m. basically.
7 to 2 p.m. 7 to 2 p.m. And by 3 p.m. you reach home.
By 3:15,
By
3:50
3:15 or
sometimes.
3.
Depends.
Hmm, hmm. Okay. You are having really a tight schedule. And when is your next physics exam?
I'm gonna have class on Thursday. We have PTCS, so I don't have any school on Thursday.
Hmm.
I take a class under the day, anytime I'm free.
Okay, okay.
Except for me.
No problem. When is your next physics exam?
They haven't shared the date.
Okay, okay. And what will be the syllabus for that?
The syllabus,
Mm-hmm.
the entire, sir,
Mm-hmm.
the entire portion,
Entire entire syllabus.
front to back, both back books,
Both books.
and now you can see what I'm breaking out. Yeah.
Okay, let's focus on the topic which we are doing. Because if we look at the entire syllabus, then we will not be able to do anything. Okay, the next topic is phasors and phasor diagrams. Phasors and phasor diagrams. Phasors and phasor diagrams. So this is basically to understand what is phasor and phasor diagram. This is basically to correlate. This is basically to establish a relationship between an AC wave and a circular plane. So how can we do this? Just do one thing. We draw a horizontal line like this, and on this horizontal line we draw a vertical line here just to show x-axis and y-axis, and then we draw another vertical line like this. So here we are going to draw this one, an AC wave. Here we are going to draw an AC wave. An AC wave is like this: sine wave, then circle. We will draw a circle. And now what we are going to do here is we are going to match this wave with this circle. How we are going to match this? The maximum value of this current, this is current, and here we have omega t. This time I am going to show omega t. Omega t, what is omega t? Omega t is nothing. Omega t is angle. Omega t is theta. So we are going to show omega t on x-axis here and I current on y-axis. So what is the maximum value of current? Maximum value of current is this one. This is I naught. This is I naught. Maximum value of current, we call it as amplitude of current. So this is I naught. Now this I naught, the length of this I naught, we will take this length of this I naught as the radius of this circle. And if we, from different points, if we draw perpendiculars on this circle, first of all, what I have done, first of all, I have made this AC wave. Then I have noted down what is the maximum value. What is the maximum value of current? The maximum value of current is I naught. I have measured the length of that maximum value, and then taking that length as radius of a circle, I have drawn a circle on the same horizontal axis. Now, any point you take, any point. Suppose I take this topmost point and I draw a perpendicular here. Perpendicular is called projection. Projection. I draw a projection here, then it touched this circle, it touched this projection, touched this circle at this point, So we just join this point with the center of the circle like this, and then we have find out what is the angle between x-axis and this radius. What is the angle? This is 90 degree. That's why we mark here pi by 2. Pi by 2 means 90 degree. All right, is this clear to you? Is this clear?
No.
Another thing I am going to tell you. Now, this we have taken the maximum point, the peak point. Now take any other point. I have taken this point. Now from this point, draw a projection here. From this point, I have drawn another projection. Now this projection touched the circle at this point. It touched the circle at this point. Now from this point, join the center of the circle. Join the center of the circle. The center of the circle is this one. And now find out what is the angle. Now find out what is the angle. So angle is, this time if I am finding out, angle is 60 degree. 60 degree. So at this point I will mark 60 degree here. 60 degree means pi by 6. Pi by 6. Is this clear? Is this clear? So any
I don't
point,
understand what these diagrams are and what they're for.
actually I am going to represent, I am going to show how this AC wave is related with the circular plane. You can see any question, you can see any diagram in your book which you have taken. I think that one, exam idea. So in that book also, or if you have any other book or NCRT, in that book also you can see this type of AC wave. They simply write it like this. They simply draw it like this, and they write here pi by 2, and at this point they mention pi, and at this point they mention 3 pi by 2, and here they mention 2 pi. So they simply say that in one cycle of the AC, the angle covered is 360 degree. In one cycle, AC covers complete revolution of a circle. That means 360 degree angle it covers. But we fail to understand what is this pi by 2. What is this pi? Where this angle pi by 2 is? So just to understand that, I am drawing this, I am relating this one with a circular plane. And when we relate this AC wave with circular plane, then this type of circular plane diagram is called a phasor diagram. So I am trying to explain that one to you. All right. And in the similar way, they have in most of the questions they write pi by 2 here and pi here. What this pi means? Okay, from if this point is pi, then what? How can we relate it? This is pi. How can we relate it? Simply try to connect this point with this circle. So we are trying to connect it like this, like this, like this, like this, and we are going to join it at this point. We are going to join it at this point. So what this point is all about? This is 90 degree. This point is 180 degree, as you have studied in the maths quadrant rule also. This is 0 degree. This is 90. This is 180. This one is 270 degree. And this one is again, this 0 degree is 360 degree. And 360 degree is nothing but 2 pi. So this is called a phasor diagram. Phasor diagram simply tells us that the angle, simply tells us that how we have written pi here, pi by 2 here, and 3 pi by 2 here, and 2 pi here. All right, is this clear to you? So any instant, you take any instant. This one, this portion correlates to this one, first quadrant. This portion correlates to second quadrant. This portion correlates to third quadrant, and this portion correlates to fourth quadrant. The first, second, third, fourth. All the four quadrants gets completed when one wave of AC gets completed. This is all about phasor diagram, and then I am going to tell you different types of AC circuits. Then you will get to understand this phasor diagram more clearly. Okay, and why we are studying it, the purpose will also be clear to you. So let's move on to the next topic. In your notes, page number 11, AC circuit containing resistance only. I'm going to tell you the topic, and in that topic this phasor diagram will be more clearly elaborated to you. So AC circuit containing resistance only. Next topic. A little bit might you have understood a little bit in this one.
Yes.
Okay. I will see in the next topics. AC circuit containing resistance only. AC circuit containing resistance only. So this time I am going to study this one, a simple AC circuit where we have only a resistance. So there are three types of devices which we are going to study here in AC. One is resistance. Resistances are, one is inductance. Inductance is L. One is capacitance. Capacitance is C, RLC. So AC circuit containing resistance only. Suppose a resistor of resistance R is connected to a source of alternating EMF E given by E is equal to E naught sine omega t. Suppose we have a circuit like this, and this is resistance, and this resistance is connected to a alternating source. Alternating source is this one. Alternating source is represented by this symbol, a circle, and in that circle we make this wave, like this, we make this wave. So this represents that this is an AC source of voltage. So E is equal to, this is E naught sine omega t. This is E naught sine omega t. Such a circuit is known as purely resistive circuit. This type of circuit which contains only a resistance, that type of circuit is known as purely resistive circuit. If I be the current in the circuit at instant t, then the potential drop across R will be IR. Potential drop across R will be IR. So I, this voltage source is delivering the current I. We always take one terminal as positive and one terminal as negative, and we should know that the current always leaves from the positive terminal, goes through the resistance and reach to this negative terminal. So as per KVL is Kirchhoff's voltage law. Are you noting down?
Yeah, writing.
Okay. As per KVL, what is this E naught sine omega t? It is nothing but E. So as per KVL, we can start from any point and we can add from that and at that point. So if we are starting from this point, then negative terminal is coming first. So we will write minus E here. After that, this resistance is coming. Then what is the voltage drop in this resistance? Voltage drop in this resistance is I into R. Whenever we have a resistance, then in a resistance, voltage drop in a resistance is I into R. So minus E plus IR is equal to 0. So minus E is equal to minus IR. This negative sign will get cancelled out by this negative sign. I is equal to E is E naught sine omega t is equal to IR. So I is E naught upon R sine omega t. So our purpose is just to check out that initially we have taken the EMF of this voltage source as E naught sine omega t. E is equal to E naught sine omega t, and with the help of this E is equal to E naught sine omega t, I want to establish a relationship. I want to find out the relationship between I and I naught. What is I naught? Maximum voltage upon resistance is maximum current. So I naught, I is equal to I naught sine omega t. With the help of E, I want to find out the value of I. So in this case, where the circuit contains only a resistance, I is equal to I naught sine omega t. And what it shows that here E is equal to E naught sine omega t. So sine is having what angle? Omega t. And here sine is having what angle? Again omega t. It means that current and EMF and current both are in same phase with each other. Means there is not any angular difference between both of them. So EMF and current both are in phase with each other. Therefore, I and E are in I and E are in phase with each other. Is that clear to you? Are in phase with each other because both are making the same angle. Both are making the same angle omega t, and this is also making the same angle omega t. So when current and EMF both are making the same angle, it means that they both are in phase with each other. Is this clear?
Okay, so if each question will come from numerical of this way. So if I have a numerical, what do I use? Which formula?
Uh, actually, actually, initially you have to understand what is an AC circuit which contains only a resistance. Then we will understand what type of circuit is that which contains only an inductance. Then third type of circuit which contains only capacitance. After that, we will study the combination of resistance, inductance, and capacitance. So in total, I will teach you four type of circuits, and on that four type of circuits, questions will come. I have included numericals also in my notes, and when you do that numericals, then slowly you will gain confidence on that. Okay, so first of all you have to understand, and sometimes they ask this derivations also. They ask that please find out the value of current in the case of an AC circuit which contains purely a resistance, which contains a resistance only. And after reaching at this point, I is equal to I naught sine omega t, they will ask you draw a graph between E and I, and then they will ask you for a phasor diagram also, that you have to draw a phasor diagram. So with the help of this, we will draw a phasor diagram also. Okay, so you just try to understand only this small things which I am telling you. From here to here, is this clear to you, that we have started with E is equal to E naught sine omega t. In this chapter, if you suddenly try to jump to the last topic now, then you will not get anything. Are you getting what I am trying to say? So we have to understand these small topics, otherwise the last topic is RLC series circuit. That will be that you will not be able to understand. So first of all, we have to slowly understand these things, and please stop worrying about that thing, that the entire syllabus is coming and we are having very less time. If we do small things, if we do small chapters with great precision na, then you will gain more confidence, and you will believe me, you will be able to complete all your syllabus on time. Okay, I will also try to take some extra classes, because here also I am having some tough time, but again I will try to do my best. Okay, Anusha?
Yes, sir.
E is equal to E naught sine omega t, and I is equal to I naught sine omega t. And I am not so much fluent in English. Sometimes you might be, sometimes you feel little bit difficult to understand what I am saying. So what I try to say, you understand na, all the things?
Yeah, your English is fine, sir.
Okay. Actually, I am a technical teacher, so my hands on this language is not so good.
It's okay.
Okay. So, okay, and you can ask anytime. You can ask, "Oh, sir, what you are saying. I'm not understanding anything." So I will try to explain. I will try to explain it again to you. Okay, because the main mode of teaching here for the last 12 years I am teaching. So the main mode of teaching, the main mode of communication teaching here is Hindi only. So in Hindi I'm very much fluent, but trying to explain all the things in totally English, so it takes a little bit. It is little bit difficult for me, but I'm still trying. Okay. So the next thing is graph of E and I on page number 12. E comma I. So graph of E and I versus omega t. Versus omega t means E and graph of E and I with omega t. Omega t is theta. So this is an AC wave. So this wave is of EMF. This wave is of EMF. And what is the maximum value of EMF is E naught. It is E naught. Okay, what is I? I is equal to E naught upon R. It means that E naught, it means that EMF is getting divided by resistance. EMF is getting divided by resistance. So obviously the value of current is always less than EMF. You please try to understand this thing. This is a very basic concept that value of current is always less than the value of EMF. From the last question which we have done here, that in this question also, okay, we have not calculated current here, na? We have not calculated current here. Okay, leave that. Just try to understand. Just keep it in mind that value of current is always less than the value of EMF. So we will draw a graph of I here, because I is also varying like this. The angle of I here, sine omega t, it is sine omega t, and it is also sine omega t here. Means they both are in phase with each other. So I will also move in the same way as E is moving, like this, but with a small value, because value of current is always less than the value of EMF. Okay, so this graph was of E and this graph was of I. E is equal to E naught sine omega t and I is equal to I naught sine omega t. On x-axis we have omega t here. This one is 0, this one is pi by 2, this value is pi, this value is 3 pi by 2, and this value is 2 pi. This value is 2 pi. So this was graph of E and I versus omega t. Now we will draw phasor diagram for a resistive AC circuit. Resistive means an AC circuit which contains only a resistance. Resistive AC circuit. Okay, now this is x-axis and this is y-axis. Whenever a phasor diagram, whenever they ask us to draw a phasor diagram, then we always draw x-axis and y-axis. Whenever they ask to draw graph between E and I and omega t, then we take omega t on x-axis and we take E comma I on y-axis. Here phasor diagram, for phasor diagram we take x on x-axis and y on y-axis simply. This is phasor diagram of resistive AC circuit. Phasor diagram of resistive AC circuit. Now here what this EMF is making angle with the x-axis. EMF is making angle omega t with x-axis. So this is EMF. I have drawn a single line for EMF. This is E naught. Maximum possible value of EMF is E naught. Obviously, current is always less than EMF. And this E naught is making what angle? EMF is making omega t angle with the x-axis. In the same way, I is also making the same angle. They both are in phase. They both are in phase means they both will lie on the same line and they both will make angle omega t with the x-axis. I naught is less than E naught. That's why I am drawing this arrow of I naught a little bit behind E naught, just to show that I naught is less than E naught. This is phasor diagram. Okay, and they have shown one thing. We always know that if E naught is like this and angle is omega t, then the horizontal component of E naught will be along the x-axis, and that is called E naught cos omega t. But I am not interested in E naught cos omega t. I am interested in E naught sin omega t. Where will be that sin omega t? Sin omega t will be on the y-axis. Understand what I am saying? Anusha, are you getting it?
Yes.
Look, if I draw the horizontal component of E naught, horizontal component is always along the angle. It is E naught cos omega t, and this is E naught cos omega t. E naught cos omega t. But I am not interested in cos omega t. I want to know what is sin omega t. So sin omega t is always here. E naught sin omega t. Let's write like this. This is E naught sin omega t. In the same way, I naught sin omega t will be here. I naught sin omega t. Is this clear to you till now?
Yes.
Okay. So for today you have to do only till here only, and tomorrow I will do AC circuit containing inductor, containing capacitor, and we will do RLC series circuit also. Resistance, inductance and capacitance together. So tomorrow we will do that. Okay, at the same time. So you have to revise till now. You have to revise this chapter till page number 12. Page number 12 of the notes.
Okay.
Okay. But keep revising it, otherwise it will not stay in your mind.
Mm.
Okay, Anusha. Okay.